Okay, so exponent, 1 less than the exponent, times the derivative on the inside. So when we simplify that, you get 6, and you can either leave it as 4x plus 5 to the 1/2, or 6 times the square root of 4x plus 5. How'd we do? Anybody questions? Nope, because 3/2 minus 1 is just positive 1/2.
Oh, minus 1.
No, it's always the exponent minus 1. Yep. Like, let's go back to go back up to this guy up here. See how it started with a 5 way up top, and then it's 2x plus 3 to the 4th. Yeah. It's easier with whole numbers to remember what's happening when you get with the fractions. Alright, so let's try again. Try number 3 for me. Let's see how you do. So again, h of x I would rewrite as x cubed minus 1 to the 1/2. So then our derivative would do our exponent. X cubed minus 1, and then subtract 1 times 3x squared. So, in your numerator you'd have 3x squared, and then over 2 times either the square root or x cubed minus 1 to the 1/2. Yeah, don't do that. Yeah, just leave it as a fraction. Okay? And everybody's good with no negative exponents, like we understand. Don't leave it as x to the negative 1/2. Okay. How many got that one right? Yes? Okay. Alright. So, let's try this one. Remember, you could rewrite this. So this could also be 2x times x minus 1 to the negative 1/2. So guys, I'm putting a couple things together here for you. You've got to do the product rule and you have to do the chain rule. Okay, so try, and then we'll go through it. We'll see how you did. Okay, think about product rule. So guys, you definitely start with the product rule. It's when you're finding the derivative of the second piece that you have to do the chain rule. Try. Fearful that we're wandering down the wrong path. Yeah. Okay. All right, let's go through this one together. So, for the product rule, remember, like if we started with this, let's just review product rule. Derivative was g of x times f prime of x plus, right? Like that's familiar, right? We've been doing that. Okay. So I'm going to go with this one just because I think it's easier. So for me, I know our letters are switching here, the derivative of our g. So I'm going to start with, just leave this one alone. Okay. And then it's going to be times the derivative of this guy. So times 2, right? So that piece is simple. Plus, now we leave 2x alone, yeah, Anna? Because it's two things multiplied together. Yeah, that's what you have to start recognizing is you are going to use the chain rule here when I find the derivative of this second piece, but it's of two things multiplied together, so you have to do product rule as well, okay? All right, so then now I have to use chain rule to find the derivative of this, so it's going to be times negative 1/2 times x minus 1 to the negative 3/2 all times 1, right? So this piece is where you use the chain rule. Okay. And we get to simplify. So this would be 2 over, again, I don't care which way you write it, square root of x minus 1. Then it's going to end up being minus, right? And it's 2x times negative 1/2, so that's just going to be minus x over, this will be the square root of x minus 1 cubed. I don't need minus square roots there. Are we okay to there? What if I asked you to find a common denominator and add these together? You'd cry. Oh no. Okay, so let's think about it. I'm going to rewrite this. This one I'm leaving alone. So if I have the square root of something cubed, isn't that really going to give me that? Isn't that what that means? Okay. So now what do I need? No, do we not see? So think about, like, if it was the square root of x cubed, wouldn't that be x times the square root of x? Yeah? Okay. Sometimes simpler is simpler. Okay, so that's what I did. Just what's under there, order them out, and then like the other there. So what's the only thing I actually need to multiply by here to find a common denominator? Yeah. So your final answer, I'd have 2x minus 2 minus x all over x minus 1 times the square root of x minus 1. So what do we really get? Yes, over all of that nonsense, exactly. Okay? So guys, that's really the only way the chain rule gets tricky, is when it's product or quotient rule with the chain rule. You just have to slow it down a little, make sure you're finding every piece. Just go back to the basic formula to make sure you don't miss something. Questions on that one anywhere? Okay, let's try a couple. Okay, I'm going to pick a couple for you to start with. Let's try. We'll do 2. I think you're good with 2, but let's try that. That's just basic chain rule. And then try number 3 also, because that's throwing in chain rule plus product rule. Okay, so let's try those 2. See where we are. So try these guys, talk to each other. It's just going to take some practice. All right, guys, how we doing? What? Number 3 is long. You do not have to multiply it out completely, because don't you just have like something times something times something? Yeah, as long as there's not something times something plus something times something, there's no need to multiply it out. All right, guys, so first let's look at number 2. Did you get 10 over 3 times 5x minus 1 to the 1/3? Yes? So basic chain rule we get, right? Okay. Chain rule and product rule is where it gets tricky. Did you get... Let me put the answer up first, and then I'll see if you want me guessing when we go through it. But for sure. 4 times x squared plus 3 times 10x squared minus x plus 6. No. Okay. Well, that's good. Oh, it's 10 eraser. It's product. You use the chain rule to find the derivative of the first, like, piece of the product, but it's product rule. You have to follow product rule, okay? Chain rule is just to find the derivative of one thing. So it can't be used solely if you've got multiple things that are multiplied or divided or anything like that, okay? All right, so let's start this one. So I would be doing, here, I'll color code. So this guy I'm going to do in green. This one I'll do in blue. So 8x minus 1, and then times the derivative of that first quantity. I cannot just do power rule there. That is going to be chain rule. So it's going to be 2 times x squared plus 3 to the first times 2x. Yeah? Okay. Plus. Then we're going to do, let's see, I'll stay in for x squared plus 3 squared times, what's the derivative of my green guy? 8. Okay, did we get there? Yes. Okay, so it was, you know, Algebra 1 that messed you up then? It usually is. It's usually the calculus, totally fine. It's like, oh, we gotta multiply stuff? That's where it gets sketchy. Okay, so let's try. So I'm gonna leave this alone for a minute. And then just making sure we see it. We okay with that? Okay. If I square this real quick, that'd be x to the 4th plus 6x squared plus 9. Okay. Yeah, it's okay. So, let's do... we'll do these two first. So 32x squared minus 4x, and then times x squared plus 3. Still with me? And then I will be done with my parentheses on this one. So 8x to the 4th plus 48x squared plus 72. Okay. We're getting close. I'm running out of room, but you know. So now if I multiply this all out, so that's going to be 32x to the 4th. Plus 3 times 32, what, 96? X squared minus 4x cubed minus 12x. And then plus all of this. I don't know why I gave you an answering factored form, but that's okay. Alright, final step. Let's see. 40x to the 4th? Yes. minus 4x cubed, yes. Plus, let's see, what's 96 plus 48? What'd you say? Yes. 144x squared. Do I only have the 12x?
No.
Yeah, minus 12x plus 72. Okay, is that happier?
Yes.
Did we get that?
Yes.
Yeah, I just scribbled it out. That's fine.
What was the
So it's just part of it. It's just a different way of doing it. It's factored form of this, but it's fun. And just do this. Are we okay with that? Yes? Okay. Are we getting better? All right. Try number 6 for me. 6 is actually really easy, but I just want to see if you get confused at all. And after you do this one, I'll go back and show you why I had the answer I had on 3. Guys, what if it said 2x plus 3? What would the derivative be? Okay. Nick, stay focused. Nick, you're still not focused. Okay. Alright guys, for y prime, let's see, did you get 3 times 2x plus e squared times 2, so 6 times 2x plus e squared? Yes. Okay. Let's go back and look at this one again, and I'll show you why I factored the way I did. I'm just going to do it on a new page. So you were good with, let's see, x squared. I feel like I had this in the other order. Let's see. You were okay with that, right? Okay, you can actually factor this. I know. I think it's good for you guys to see this though. Would you agree that both, like, this whole thing is one term and this is another term, right? Okay, do you see how they both have an x squared plus 3? I know this one is squared, but they both have that, right? And then I see I could take 2 and 2x, that'd be 4x, right? Ooh, let's not take the x though. 2 and 2 is 4. Could I take a 4 out of that? Okay. So I could factor out from this a 4 and an x squared plus 3, right? Times, that would leave me with, this would still be there, right? And let's see, my x would still be there from this one. What squared? On out of this, yes. Yeah. And out of that 8, what would be left? 2. So it's a smaller amount to multiply if you wanted to do it this way, because this would be 8x squared minus x plus 2x squared plus 6. If you recognize it, this way is definitely easier. But you have to see it. Okay? Does that make sense to you? It's factoring. What? You would not have to multiply that out because there's nothing else to like add together and combine. Okay? Alright. Let's go back to the other page. Let's do a few. I don't know what I just did. Let's see. Let's do 8. Don't overthink this one, guys. Is ln of 2 a variable? So you don't have to do product rule. I mean, you could, but one term of your product rule is going to cancel out because what's the derivative of the natural log of 2? So there's no reason to do the product rule because it would be gone. So you just have to do chain rule. It looks weird. You were all excited. Yeah, I don't expect you to evaluate that now. What else I want to give you? All right, guys, did you get that?
Yeah.
Yeah. Less scary than it looked? Anybody need me to go through it? So I would start just by rewriting, like think about your original as that, okay? So then the exponent times, the constant that's there is just still there, that's fine. 5x minus 1 to the negative 1/2. And then times the derivative of the inside. So when you simplify, in your numerator is 5, the natural log of 2. Denominator, 2, and 5x minus 1. So if it's a single term, like let's say it's x cubed, and I said find the derivative of that, power rule, cool. If it's quantity cubed, you can't just use the power. I mean, this one it works, okay, let's put 2 in there, so it won't just work out nicely. Then you have to do, like you've got to have that extra. Do you see the difference? Yeah, go ahead. All right. 10 and 12. Try those. Don't I understand? try telling you all. All right, guys, we good? Let's see. So guys, think of this as 1 plus x to the 1. So your derivative is 1/2 times 1 plus x to the negative 1/2. Yes, on 10? Yeah? Chain rule by itself, easy? Okay. It's just everything together that gets messy. Alright, so 60 times 2x squared minus 4x plus 1 to the 59 times, anybody want to multiply that out? 59 times, no, me neither. Times, that's not fun. 4x minus 4. I'm fine with that. If you feel like multiplying the 60 times the 4x minus 4, you certainly can. If you want to factor a 4 out and take that times 60 and leave it as x minus 1. But this is fine. Okay? How'd we do? Yeah. I wouldn't, just because the whole thing's raised to the 59. If it didn't have an exponent, then yeah, go ahead and factor it and see if anything else factors out. But there's absolutely no need to do that because it's to the 59. You could factor, like you could turn this into that, and then take the 4 times 60 and say 240.
You know, a robot that cuts your grass so that you don't have to do it yourself.
Like, that's fine. Okay. Alright, guys. Let's do one more. And then I'll give you a little time. Let's do 14. Now, guys, this one looks scary because there's so much going on in there. But you can do it. It's basically chain rule a couple of times.
What does that even mean?
So you start with the chain rule, but then part of the chain rule is taking the derivative of the inside, right? You have to do the chain rule to take the derivative of the inside. It sounds scary, but it's really not that bad. So you know how part of the chain rule is to take the derivative of like what was in the parentheses? Well, in this case, to take the derivative of what's in the parentheses, you do the chain rule again. You will. I know you can. Nope, we are not doing second derivatives yet. That comes later. Like unit 11 later.
What? This makes sense.
Yeah.
No.
Yeah, unit 11 will do the second derivative test. But that's a while. We'll go that long, but we'll get there. It's quest, yes. I'm gonna let you try another minute here. Don't be scared. Don't be afraid you're gonna do it wrong. You'll be fine. Don't go crazy multiplying. You shouldn't have pluses in between any of your parentheses, right? Okay, then stop. Are you scared? What do you mean keep going? All right, guys, let's look. You're panicking. Okay. Sky and purple. So, for my derivative, I'm going to start exponent's 8, right? So 8 goes in front, and then it's times everything that's in parentheses. And what's my exponent going to be now? 7. We're okay with that, right? Times the derivative of the inside. Well, the derivative of 3 is nothing, so we don't have to worry about that. So really we're looking at this x cubed minus 2x to the 5th. Well, I have to use the chain rule to find the derivative. So what's the exponent? 5 times that quantity to the 4th, then times the derivative of the inside, which is 3x squared minus 2. Okay, yeah. Not that bad. It just looks scary. So you can multiply a little here, but there's not a lot to do to get your final answer. Like you can do the 8 times the 5. And then this is still all to the 5th to the 7th. And then x to the 5th minus 2x to the 4th. And then 3x squared minus 2.
Who loved that first? That's the big one. How would you? Because it looks like the 5 is inside the parentheses, like inside the 5, so I would.
Right, but it's all multiplication, right? It's not like 5 plus something times something else. It's just 5 times it. Like, so you can just do.
I guess.
Yeah. How many got it?
Nah.
Okay, good. Yay. All right, questions. Okay. Homework is on your assignment sheet. You guys got a little more than 10 minutes left, so you guys can work.
So when it says a worksheet on the assignment sheet,